Good evening, my dear students. So it's a long journey of differential equation. Now we are arrived at chapter the homogeneous linear equation. There are so many discussions on linear differential equation with constant coefficients, and we have learned how to calculate the complementary functions, particular integral in different cases, and so on. So in this chapter, let me start with the very well-known linear equation of nth order. dny dxn plus p1 dn minus 1y dxn minus 1 etc. pn minus 1 dy dx plus pny plus equal to q, where p1, p2, pn and q are constants or functions of x. But in this chapter, we'll assume that the coefficients p1, p2, pn are constants in linear differential equation with constant coefficient. If we are talking about a chapter, but in both the cases, it will be a linear equation, whether it is a function of x or it is a constant. Now, a equation of the type xn x to the power n dny dxn plus p1 x to the power n minus 1 dn minus 1 y dxn minus 1 etc. pn minus 1 into x dy dx plus pny equal to fx. So where p1, p2, pn minus 1, pn, these are all constants, not functions of x. These are all constants. And you see, you have x to the power n, so you have nth order derivative. You have x to the power n minus 1, you have n minus 1th order derivative. You have x, so you have the first order derivative. This type is known as Euler's homogeneous linear equation or Cauchy-Euler equation. It's a very famous equation. So this type of equations, now my topic in this chapter, how to solve this type of differential equation. So I will teach you that part. So after this lecture, you will learn how to solve or how to nurture with this type of differential equation. Now it may be transformed into linear equation with constant coefficient. So my first target is to transform this type of linear equation. Let me numbering this. Let me numbering this one as 1 and this one as equation 2. So it may be transformed into linear equation with constant coefficients by means of the substitution x equal to e to the power t or t equal to log x. So your standard substitution in all this type of problems are x equal to e to the power t. So naturally t equal to log x. So if you differentiate dx dt equal to x, so that dt dx equal to 1 by x. Okay. Now, suppose once again, so how will you convert the equations of the second order? So I am considering second order differential equation. So your second order differential equation will be looks like d2y dx2 x squared, right? X squared d2y dx2 plus x dy dx, right? Plus suppose this is p, this is qy equal to r. pqr all are pq are constants and r is a function of r may be function of x. This type, this is your second order differential equation, right? So equations of the second order, how will you convert the derivatives? So already we have seen that dt dx is 1 by x. So your dy dx can be written as, look at that, your dy dx can be written as dy dt dt dx. So dy dt is 1 by x. Dt dx is 1 by x and into dy dt, right? So 1 by x dy dt. So that is x dy dx equal to dy dt. Look at that. If you cross multiply, it will be x dy dx dy dt. So this is the conversion of your x dy dx. Look at that. Your equation having x dy dx. You can see this part. You have x dy dx. So that will be converted into dy dt. A simply derivative. X is not there. So if you write d equivalent to d is an operator, capital D, that is equivalent to d dx, and theta equivalent to d dt, then x dy equal to theta y. So this is converted into x dy equal to theta y, right? Now your second order part, d2y dx2. How will you convert d2y dx2? d2y dx2 can be written as ddx of 1 by x dy dt, right? Because your dy dx is 1 by x dy dt. So if you differentiate, it will be like this. It will take the form of like this, 1 by x squared times d2y dt2 minus dy dt. Now if you take the cross multiplication, your x squared d2y dx2 will be in terms of d2y dt2 minus dy dt. That is in terms of theta square minus theta, because your ddt is equivalent to theta, operator theta. So I have introduced another operator theta for ddt, and d is a well-known operator for ddx, right? Equivalent. So x squared d2y is equal to theta minus 1 into theta y. So this is the conversion of x squared d2y. So look at that. Your second order differential equation x squared d2y dx2 is converted into that type. Similarly, you can convert the third order also. Third order x cubed d3y dx3. That will be, you can check that, that will be of the form this. And if you take the factors, that the factors will be theta minus 2 into theta minus 1 times theta y. So this is the form. So on. And if you suppose, if you suppose you have x to the power 4 d4y, so how will you convert this? Theta minus 2, you have to start from theta minus 3, right? So your factors will be theta minus 3, theta minus 2, theta minus 1 times theta, right? Okay, into y. So these are the factors, and so on. The process goes on, right? So this is how you can take the advantage of this calculation. A new operator theta has been introduced, right? Now let's solve a problem in front of you so that you can understand the things. So you see, our problem is x squared. It's a second order problem. So second order differential equation, linear homogeneous differential equation. You see, you have x squared, second order derivative. You have x, first order derivative. So this is the identification of this type of differential equation. Now if you take, this is your homogeneous linear. So how will you solve this differential equation? What is your substitution? Your standard substitution is x equal to e to the power t, right? Your standard substitution is x equal to e to the power t. So naturally your log x is t, and you get dt dx as 1 by x, dt dx as 1 by x, and you convert similarly. So look at that, dt dx is 1 by x, and x dy is theta, already shown that x dy can be written as theta. Here we have shown that, yeah, x dy is theta because of this calculation. The calculation is in front of you. So, and x squared d2y is equal to theta minus 1 theta, because you have the highest order derivative is theta, second order. So you have only restricted to this part. You don't need to calculate third order. Then your given equation transforms to, if you substitute in the given equation, so this will be theta minus 1 into theta, right? And minus, this will be theta plus 4, right? And whole y, right? So this is your left hand side, and you look at that, your right hand side is having x squared. So it will be twice e to the power 2t. This is the equation in the present form. This is the differential equation in the present form. So now this is your linear differential equation with constant coefficient. So our first target is to convert the homogeneous linear equation to linear equation with constant coefficient. So this is your form and this is your simplified form, right? And the auxiliary equation is m squared minus 4m plus 4 equal to 0, and your roots are equal. So values of roots are 2 comma 2, roots are real and equal. So you can write the complementary function in this case, but remember theta is equivalent to ddt. Don't forget that theta is equivalent to ddt. So you can write, okay, let me finish the calculation. It's a hint for you. So this is your so your complementary function in this case is, if I write the complementary function, c1 plus c2 t, because your operator is theta is equivalent to ddt, right? So c1 t e to the power 2t, right? And your pi, in this case you have to calculate the pi. Your pi will be 1 by d theta minus 2 whole square, right? You see, you have this form, theta squared minus 4 theta plus 4. So you have 1 by theta minus 2 whole squared e to the power, on the right hand side you have twice e to the power 2t, right? You see, on the right hand side you have twice e to the power 2t. So this is your pi. So 2 and e to the power 2t, because if you substitute 2 replacing theta, it will vanish, so it will undefined. So you can replace, you have to replace theta by theta plus 2. So you have theta squared 1. So twice you have to integrate 1, so that will be t squared by 2. So ultimately you have t squared e to the power 2t is the pi. So finally your general solution is CA plus pi, right? You have to write that complementary function plus particular integral, right? So your complementary function is c1 plus c2. Now you can replace your t by x, because your final calculation must have x. So your t is log x, so you can replace t by log x, and e to the power t is x squared, and you have the pi as t squared e to the power 2t, so it will be log x squared, right? Log x whole squared and times x squared. So this is your answer. This is your complete general solution, complete primitive, that is CA plus pi. This is how you have to deal with the problems of homogeneous linear. Next we have another problem. Let me share with you. 5 plus 2x whole squared d2y dx2 minus 6 5 plus 2x times dy dx plus 8y 8 into 5 plus 2x whole squared. You see, here you don't have any term having x squared, but instead of that you have 5 plus 2x. It's just like you, if you replace this is by x, this is x squared, this is like x, and this is also x. So you have the same homogeneous, because this is squared and you have multiplied with second order derivative, and this is x, you have first order derivative, like this, and so on. So what is your substitution? Your substitution is not x equal to e to the power 2t, but your substitution is 5 plus 2x as e to the power t, right? 5 plus 2x as e to the power t. Now you have to do the same calculation what I have taught you, right? So in this case you see 5 plus 2x as e to the power t, so that you differentiate, you get the value of dx dt, that is e to the power t, that is equal to 5 plus 2x. So again you can write dy dx as dy dt, dt dx. So your dt dx is twice over 5 plus 2x times dy dt. So your 5 plus 2x times, if you take the cross multiplication, you have 5 plus 2x dy dx as 2 dy dt. Now your 5 plus 2x dy dx, that is this term, you look at that, this term is replaced by 2 theta, right, where theta is equivalent to ddt. So this is the same calculation. Only thing is that you have to identify the equation, right? This is very, very important type of problems. You have to identify the problems and you have to do the same calculation. It's a very simple calculation. Now you have to learn about the second order, how to calculate the second order derivative, that is d2y dx2, that is ddx of this. And you can check the calculation will be 4 by 5 plus 2x whole square d2y dt2 minus dy dt. Again, if you take the cross multiplication, that will be 5 plus 2x whole square d2y dx2, 4 times theta square minus theta into y. So that is equal to 5 plus 2x whole squared d squared y, 4 of theta minus 1 into theta. So that will be converted into this. So what is the difference between that and this? There is a 4 here. You have 4 multiplied. So if you take only x as e to the power t, that will be your error. There will be error in your calculation. And d is equivalent to d dx, theta is equivalent to d dt. Always remember. So after that, if you do the simplified, if you substitute in the given equation, that is replacing 5 plus 2x whole square d2y dx2 in terms of this, and your first order derivative in terms of this, and plus 8. So you have this type of simplified form, and this is your homogeneous, not homogeneous, but it is a linear differential equation with constant coefficient, right? And you can check that your complementary function can be written as, you have real roots, b square minus 4 is greater than 0. So your complementary function will be like a is an arbitrary constant, e to the power 2 plus root 2 times t, right? Because you have t ddt, and b e to the power 2 minus root 2 times t. This is your complementary function, and you can calculate the pi, particular integral, right? 1 by theta squared minus 4 theta plus 2 into twice e to the power 2t. You know how to calculate that. I'm not talking about that calculation. You can easily find out, because already in my previous videos we have this taught you about this, how to calculate the particular integral. Different cases, there are some complicated cases also. Okay, so these are the things, and you can check the calculation, and finally you can get the solution. Lastly, you have a third order differential equation, homogeneous linear differential equation, third order. So let me show you so how to convert this into constant differential equation with constant coefficient. So this third order will be converted into, if you write theta into theta minus 1 into theta minus 2, right? Because it's a third order. And the second order will be twice theta into theta minus 1, right? Plus 2 times y, and your right hand side will be x will be e to the power t plus e to the power minus t, right? E to the power t plus e to the power minus t. That is how you can calculate, and you can check the calculation. If you simplify, you will get theta cube minus theta squared plus 2y equal to 10 e to the power t plus e to the power minus t. So that is the simplified form. I'll look at that. Your new form is the differential equation, linear differential equation with constant coefficient. Okay, so that's all, and you can solve this because you can get the auxiliary equation, you can find out the roots. Suppose in this case, if you want to see, I can show you, no problem, because you have your auxiliary equation is m cube minus m square plus 2 equal to 0. That is your auxiliary equation, and if you solve, it will be factored. You can do the factorization. It will be m plus 1 into m squared minus twice m plus 2 equal to 0. So your roots will be, roots of the auxiliary equation will be minus 1, 1 plus minus I. You have complex roots, a pair of complex roots, and a real root. Yeah, cubic equation I have at least one real roots. So your complementary function will be, in this case, your CF will be C1 e to the power minus t plus, for complex roots you can write the equation like e to the power t into C2 cos t, right, plus C3 sin t. C1, C2, C3 are arbitrary constants, right? So this is the complementary function. In this case, you have a complementary function, and your complementary function can be written in terms of x, C1 by x plus x into C2 cos of log x, right, plus C3 sine of log x, right, sine of log x, right. So this is how you can write, right? And you have the particular, you can check for the particular integral. pi will be 1 by theta plus 1 into theta squared minus 2 theta, right, plus 2. Yeah, that was the factor, plus 2 into twice into 10 e to the power t plus e to the power minus t. Okay, exponential. So you can check your calculation. If it is if you substitute, it will not be 0. So you will have finally, but in the second case, if you substitute e to the power minus t, it will be 0. So in that case, you have to replace, and you have to take the inverse binomial expansion, and you do the calculation. I'm just I can tell you the answer. The final answer of the particular integral will be 5x plus 2 by x log x. That will be the final calculation. So your final general solution will be CA plus PI. Okay, that is in terms of x, but this is in terms of t, because theta is equivalent to ddt. So this is how you can deal with the problems of this type. Okay, this is our homogeneous linear differential equation, or Cauchy-Euler differential equation. Okay, all of you. So next lecture will be on variation of parameters. Follow my videos and follow my channel. Thank you, all of you.